Okay, Yufan, please. So today we will have two papers, right? The first is triple AI on 2020 papers. So it is a tree-based architecture for code generation. And based on this approach, I think the authors proposed another EJK paper to further enhance how to encode the rules of the grammar rules to boost the performance of a code generation, right?
Yes.
Okay, let's move on.
Yeah, it's the same others, and just change the position of the first other and second other. So they are almost the same team. And here is the background. So we know the Python ST. So you can look at the left picture. You can see there are several rules in this picture.
Oh, by the way, have you provided several questions for the audience?
No, I think it's quite easy, so no need to.
You still need to prepare it. Maybe you can think about the question on the fly.
Okay. For example, here in the picture, we can see many rows, and then there will be a row sequence. Maybe there is a question, which is this kind of row sequence, which all the others predicts this sequence. Anyone can answer this question?
So could you clarify your questions? So the order of the rule sequence, what do you mean?
Yeah, here you can see there's a rule sequence called 1, 2, 3, 10, 11, 13, like this. Yeah, you can see the rule sequence. So based on which order the
I see, I got it. So
predict this sequence.
So which means the traversal order, right?
Yeah, traversal order. So which traversal order?
Anyone can answer the question? Pre-order. Okay, so usually we have the DFS or BFS, right?
Yeah, yes.
Right, so which means the depth first or the breadth first. So these two options, cushion, which one do you choose?
Breadth first, BFS.
BFS. Yufan, do you agree with cushion?
Oh, no, I guess DFS. I guess root module body assigned targets. Name is 11, right? And then it turns out to be DFS.
Okay.
Yeah.
All right.
Yeah, that's so you can see there are many ways to, transfer the tree structure to a sequence structure. So there's many traverse order. So the others, these other just try one of them. So, but this actually I think it's not important. Not, you can choose any traverse sequence. In this is called pre-order traverse. This is based on the left first. That means you first traverse the left node, then traverse the right node. So it's basically the pre-order traverse. Any question for this?
Okay, you can move on. Yeah.
Yeah, okay. So, and then here is data set. So basically the others want to do the code generation task. So their natural language description is description of a card. This is a game called Hearthstone, and these are the card game. So there are some cards, and these cards have some descriptions. And here these other wanted to based on the description to generate the card of generate the code of this card. Okay.
So here the description including the image, or is it just the?
Yeah, just this is a natural language. For example, the name is dark scale healer, and there's attack and defense, cost, duration, type, player, race, like this. And also the description on the on the card, like battery, restore to health to all friendly characters. So these are all the natural language. So these are something, these are the ones to transfer to code. So you can look at the code. So the first is that its name, the dark scale healer, and the 5. That means it's maybe the defendants or cost, and then it's the code. So you just based on the description to generate the code.
So this is their model's effectiveness, or it is just descriptive?
They just use this data set.
Okay.
Yeah. Maybe in that time there's no proper data set, maybe, but I don't quite know that. Yeah, so a big difference is that this is the code generation task. So this is a grammar rule prediction. That means it generates the rule, don't generate just the code. Because we know that the code based they all apply imply to some rule. They should follow some grammar rule. So here the other just try to predict the rule, not predict the code. For example, here the ST-based code generation could be thought as expanding a non-terminal node by a grammar rule until all leaf nodes are terminal. So the task is not just like it's different from the natural language. They just generate the node on the ST tree. For example, here it first generates the root and then generates a module and then generates body. So they say based on the rule sequence to generate the code. Any question for this grammar rule prediction?
So we're gonna see more example.
Okay, there's no. I didn't put more example. Maybe you can ask some questions.
So here the question. So can you go to the formula?
Formula, okay.
Yeah, the formula. So the P code here, yeah, I can understand that it will generate a sequence of rules, right? So which means that comparing to the LSTM or transformers, so here the transformers are using the tokens, using the input and the tokens, but here to replace the tokens with the so-called rules, right?
Yeah.
So once we have the root, and the rule is the rule is not a code. So once we have now that there will be the variable assignment in these positions, or there's a function declaration in this.
Yeah.
Right.
You
So
can regard this as the AST tree, not
exactly. I'm asking, AST is just so the rule is a skeleton, and how do we fill in the content of the skeleton?
If, for example, here is the length and the 10, they are terminal nodes of the AST tree. Yeah. So they first generate the AST node like root, module, body, assign, and then the target's name ID, then it will generate the length. So it will generate the code, but based on the rule. I mean, it's on the AST.
All right. So here, I think Yufan has clarified the goals. Anyone have the questions for the input and output, model input and output? So comparing to the LSTM transformers, we starting from a natural language descriptions and generate a sequence of code, but now it's generate a nested structure of rules, right?
Yes.
Okay, let's move on.
Yeah, you can see in this formula the
Sorry, can I ask a question?
Yeah.
If we change the code token into the rules, when will make the model more complex? Because previously you just need to train or predict a sequence of tokens,
Yes,
right?
yeah. So
But
we're
now
going to
rule
see how the
first.
transformer architecture is designed.
Yeah.
So here, I think the advantage is that the code we generated is guaranteed to be syntactically correct.
Yes, I think many code generation tasks use this grammar rule prediction.
Yeah, so you can generate a sequence of tokens because people can interpret the sentence, right? But if you generate a piece of code, at least it should follow the Java code, the grammar of Java or the grammar of Python, right?
Yes. And here the Ri to R1 is the rule. So it's based on the past rule to generate the current code. Okay, so here is the module. And I think we just talk very quickly last meeting. Here, the natural language description is, I just talked the picture card description here. This is the natural language description. So they first goes with concatenate with the position embedding, and then goes for the self-attention and the gating and the character embedding, and then the convolution. I think this module is quite similar to the traditional way. For example, the self-attention is the transformer architecture, and the gating is the ARN architecture or LSTM architecture, and the convolution is is Windows, and they will reduce the length of the sequence.
Why they want to reduce the length of sequence?
They think that some information may be too long, there's some noise, so they use the CN to.
Which means that the information is not lost, but somehow aggregated, right?
Yes.
So suppose the sentence is super long for 100 tokens, but the output will be limited into 250 tokens. So they try to convolute. Am I right? Or
yes.
So the convolution is on the sequence.
Yes, convolution on the sequence.
So okay, so
maybe I ask the question for the
okay.
convolution. Anyone can understand the convolution. Maybe like if we have 10 tokens, and now we have a 3 tokens window. So how after the convolution, what is the length of the final sequence? What's the length of the predict sequence? This is the original sequence, and this is the window 3. So anyone can answer this question?
Yeah, so any volunteer to answer Yufan's question. Or maybe Yufan, you can appoint the audience.
Maybe Mengyue. Is Mengyue here? Oh, maybe.
Should the sequence be 3 at the end?
So could you talk about your process?
I mean, convolution is where you okay, maybe I can annotate.
Yeah, you can try to talk about your process, because for different process it will be different results.
So maybe you have 10 tokens, right? So if it's 3 by 3, there'll be 3, and depending on how you convolute, it'll be 3, 3, 3, 3, right? Or maybe if you convolute by 1 space, then it'll be this 3 first, then after that this 3, then after that this 3, right? So it will definitely be smaller than 10, but it depends on your stride.
Yes. So
yeah,
So
yeah,
Yufan, so your question, which means Raj is saying that you miss information or miss the clue of stride.
I think
right?
the answer depends on the, because there's many different.
Yeah, so if you want to ask the output of a convolution layer, you need to tell the people what is a stride, right?
But sometimes you can pad on the before. So there's many, condition. You can pad it here, and then here maybe.
Yeah, but whatever pattern it is, so we still need to specify stride, right?
Yes, but there are different stride. For example.
Yeah, so you need to specify the stride can either be 1, be 3, right?
Yeah, there will be many answers. So I think we can just understand the process and this procedure is okay.
Yeah, so what is number? What is your answer? What
Oh,
is
the
what is
number
correct
is
answer?
very there are many answers because if you
Mm.
have padding, if you have different stripe, if you have different, architecture.
Yeah, so suppose so anyway, so the takeaway message I just said is the convolution layers is more like a sliding window to go through the sequence.
yeah,
And we'll finally have a sequence of
smaller sequence.
with smaller lengths, right?
Yes.
Okay,
Yes,
let's move on. Yeah.
smaller sequence. Yeah. Then we go to the second module called raw sequence. So here it inputs the generated code. That means the previous code. For example, if you want to generate the module, then you previous have generated the root. So you just put the root in the generated code. And then you same as the position embedding. The depth embedding means for the S tree, because for S tree it's not, if you just use a position embedding, there's no structure information. So you add the depth embedding together. And then self-attention, same as the transformer, and the gating, same as the LSTM. And
Sorry, so the position embedding is exactly like what we're doing, NLP task, right?
yes.
And the depth embedding, but given an AST node, there are supposed to be several children, right?
Yeah.
And these children share the same depths. And how do we distinguish the position of these children? Or maybe just the order.
Pre-order sequence.
I got it.
So,
Okay.
Yeah. First the pre-order sequence and then the depth information. Then you can figure out the different.
Okay.
Yeah.
It's done.
Okay.
I mean, the approach you just finished the approach.
No. Then is the NL attention. So here we got the code and the natural language. So now we put all the natural language and the code together and calculate the attention between them. And this
Sorry, what is the raw definition encoding?
Oh, raw definition is that currently the raw, for example, here, the raw is like root module. So this raw will be represent one vector. That means you can understand as use the ID to represent the raw. That means the first, for example, is 1. So the 1 represents this raw. But the other things that this may be not quite rich information. That means it lose some information. So now they want to use the definition like they put all the root infer module, this definition to the module. Could you understand my?
So maybe I just specify. So whether there's an individual index to represent each rule.
Yeah, originally this index.
So which means that the rule definition or the rule encoding is basically a one-hot vector for the index of each rule. Yes or no?
Yes.
Okay. Yeah, so just feel free to raise any question. I think Yufan prepared the slides in a little bit brief way. So if you don't ask, you may miss some information.
Yeah, you can just ask me questions.
Yeah, but anyway, so it's good to have prepared enriched slides, because one day you will present your work in an international conference. So it's good for you to have your materials, and when people look at it, and will have an intuitive understanding.
Okay, but I think it's better to look at the overview of the region. If we list many details, then
it's good. It's good to have an overview, but this overview we definitely have a better way to provide a more intuitive visualization for this problem.
Okay.
Okay.
So now we know the rule definition is just the details of the rules, and then goes to the tree convolution. So the tree convolution is just the same as the convolution. They use another window. Here you can, because their intuition is that because now it's a sequence, so would be harder for the reader to combine the information of node with this ancestor. Because, for example, in this examples, in the past example, you can see that For example,
So
here,
do you have any slides? How do we move or apply the tree convolution on the tree?
they didn't give some example. I
And
can
have
just
they published their code?
Yeah, they published their code.
Okay.
Yeah, I can just show you
Mm.
from my understanding. So, for example, here you can see that this is a sequence. So now the problem is that, for example, this 8 row, this is 8 row. They are far away from the 3, but you can see in the tree they are quite close. So this is a problem that they lose some structure information. So they think that it's difficult for a traditional transformer to extract such structure features. So they want to integrate the features of node with those ancestors. So with the node's ancestors. Could you get the idea? So traditionally, if you want to have this information, they will be far away. So because the long dependency error, sometimes it's
Yeah,
hard
I get
to-
your intuitions, but it's
Yeah.
better to provide more technical details, how the convolution operation are defined, right? So the tree the tree may have a parent, have a lot of childrens, and the children have their childrens. And how for the traditional convolutions, it is more like n times n matrix, right? But for the tree, how the convolution is designed and how the operation has been defined, right?
It's quite easy just to put all the children's information to the parent information. It's just the same. It's now it's the window is just a 3 window. You could like a triangle. You try you
Yeah,
you
but
convolute on
but
this.
sometimes when the number of children changes, so we just aggregate all the children. So if it has 1 children, it's aggregated the encoding of 1 children.
Yes.
So if it's multiple children, it's aggregated together. So what is operation of aggregation?
Operation is put a weight on this.
Weighted sums or average.
Weighted sum.
Yeah, because you do not provide more details. But anyway, so in these meetings or in these presentations, we just given a high level and a big picture of how the code generation is designed based on the state of art. And if we are interested, we can look into their code, right? Okay, let's move on.
Yeah,
sorry, I how can the tree convolution network know who is the children, who is
because it is AST, so this rule is defined there.
is defined there.
Yeah, so you can say that the body, their assignment after the body, right? So each rule will specify the information. And also it's saying that assign is consists of targets and value. So all these are specify the rules. So you can consider the tree convolution is a convolutional operations on these rules.
Yes. It's a tree. You can just regard this as a tree.
But so maybe when you in the rule definition part, but I remember you said for this one, sorry. For this one, this will be for example, there totally 19, right? No. How many? Because
I guess it is
one
bottom
heart.
up. I understand. I guess it's bottom up. So which means that we aggregate the children first. So so each node will be aggregated, right?
Sorry, I missed. What's the question?
I think the question is that, so I think those Xiaoyan has mentioned that for rule, they have a lot of children, right? Do we need to aggregate them all, or we just aggregate their direct children?
Direct children. Just aggregate the direct children. There are only one hop. Yeah.
And another question is about the rule definition. So Profline just says one heart, right? So this may be the 1 0 0 0, then 0 1 0 0 0, right? I mean the rule definition.
Not just the after the attention, after the gating self-attention. And
I know. I just want to ask the original rule definition. So is that correct? I mean
the rule sequence is the one hot. The rule definition is based on the definition of the rule. That means for different rules, there will be different. They based on the definition. They based on the word in the definition. For example, the root
Oh,
mode.
it's
Yeah.
word.
Yeah, it's based on the word. Based on the definition. Yeah.
Okay.
It's not just a word. It's, I think, a sequence of word where we have
Yeah,
an
yeah,
index.
sequence of word. Yeah. Use another another embedding layer to embedding the definition.
Yeah. Okay. Maybe let me put a summary. Okay, Yufan, you can just move on. Yeah,
Okay.
move on. Yeah. So here we comparing to the. So it's basically more like encoder decoder structure, right?
Yes.
So it's almost like a transformer, but the difference is that the output is no longer a sequence, but the rules and or AST, right?
Yes.
So here, so you can consider this part is more like a the encoder. It's more like encoder part, right? And this part is also encoder 1. This is encoder 1,
Yes.
and this is encoder 2,
Yes.
and these were basically a decoder, right?
Yes.
So which means that for the encoder, it will taking the natural language description, and we're taking the partially generated ST, and then we're actually growing the trees by using this decoder. That's basically my understanding. Am I right?
Yeah, yes.
Right. Okay. So here now I think Yufan has finished the introduction of the both encoder, right?
Yeah, all the
Now,
info.
okay. Now you can start with the decoder.
Okay. Now is the decoder. So decoder have another input, and here the input is called the tree path. So this is just just the path on the S tree. For example, maybe I also raise an example. For example, in the
You should prepare all these examples in your preparation,
Yeah,
so that would be better for us to understand.
so I just use the same example here. So here, if we go to the assign, so the path will be the root module body. So the tree path is just the path of the AST tree. So you just put this query to the decoder. I think it's just a basic, not very naive.
And how
query.
about this rule sequence? Okay, so this rule sequence is basically on.
Where's the root sequence? Oh, you mean the encoder? Encoder is the general code, because now the code is rule, so the rule and the code can be the same.
So let me think about it. How do I the tree parse? This is so given the rule sequence, so how do we, is there any relations between the rule sequence and the tree parse?
Rule
For
sequence.
example, let's generate a code, right? So giving whatever the natural language, the natural description like this, and we generate a code like maybe A equals 1, all right? And we're saying there's if condition, right? But giving the tree, so we were convert this basically a tree node like equals A1, right? And if block, right? And there's supposed to be a root here, all right? Am I correct?
Yes, so the
Okay,
path.
so here, suppose we're generating the if condition here,
Yeah.
right? But if there's a lot of the children here, so what I'm asking is that the natural language is it's quite sure that we input the natural language description, right? And for this rule sequence, is that relevant to the partially generated AST?
Yes, it is the AST tree.
And how do we, so we feed all these partially generated AST into this rule sequence, or there's something else?
Partially generated, all partially generated rule.
Okay, so if that is case, oh, I got it. So
Yeah.
that is all partially generated rules, but in this case, this query is going to specify where we want to generate the left one, right?
Yeah, it's a path. It's not a tree. It's a path. It's a sequence. Yeah.
I got it.
Any more question for the?
Yeah, so please feel free to raise on any questions. So
sorry,
yeah,
I didn't get here the input of this one. I mean, use this as an example. What's the input of this one?
oh, the
And
input
what's
is that,
this one?
so you can see, so maybe let me rephrase.
And this is a path, so they are different.
Yeah.
Yeah,
So
I understand. But
yeah, so this part is going to specify the partially generated AST or partially generated rules, right? So if suppose we have originally partially code, we can just feed it into here. But I think we still, based on my understanding, Yufan can correct me if I'm wrong. So, but we still need to know which one we need to further generate. So here, maybe the tree was generated in a, so by the way, is the tree generated in depth order or in the breadth order, breadth first order?
The pre-order
The
sequence.
pre-order. So yeah, so I
Yes.
don't know which order is the best, but usually we were generating tree. But anyway, when we generate the tree is growing, right? The growing until the leaf node is generated. So in
Yes.
this case, we may tell the model which node should we further grow. So based on my understanding, that's how the tree path is used to specify. So by right, giving this tree path, we're going to grow this if node to grow the nodes of another if node instead of this equal node. Have I made myself understood?
yeah, I understand, but still here, it's the raw sequence or generated code. I'm
Both,
confused.
because generated code
Both.
embodies rules,
Oh, I see.
Yeah, that's the
right?
thing.
So it will tell you that a equals to 1 is basically a variable definition. It will tell you this fact. Or it will tell the model there's a fact.
Okay, so, okay, thank you.
Okay, so up until now, is there any questions? Okay, so if there are no questions, because it's fairly important for the whole process, if you have any questions, you can just interrupt. If not, let's move on.
Okay, so now we goes to the AST attention and the NL attention. So you can see the input. Here the input is the natural language, and here the input is the AST reader. So it's different attention layer, and similar to the transformer architecture. And then it will goes to a dense layer, and then goes to a softmax pointer. So it will predict the next row. So here, maybe a pointer is the copy mechanism. I don't know anyone know the copy mechanism. Copy mechanism means that sometimes we just generate the code the same as in the encoder. That means we just copy one of the token in the encoder, just a copy here. Because sometimes the vocabulary not contain all the word. So if you use the copy mechanism, you can just skip the vocabulary and just copy the word from the encoder to the decoder. Anyone have questions?
Is that the last? I'm asking. My question is that is this the last slides you talk about approach?
Yeah. Yes.
Okay, so I think it's good for you to ask questions to clarify a certain point you find may miss, right? So Jinglian, do you have any question here?
Not really.
Okay, so how about Yufan or Yunrui? And Zhang Yi, do you have any questions?
I'm hoping that there's an example to this whole process.
Okay, so kind of still confusing. So maybe I ask the last question for this slide. So when we're talking about the rule, right? So, but after all, we need to generate the leaf node, right? Hello?
Yes.
Yeah, so for example, we have already known that we're going to apply a rule of maybe the if conditions, maybe the statement definition, right? But we still need to know the name of variables. So we want to generate a piece of code, or we want to have a method call. We want to generate the name of a method call. And how does this architecture support that? Or how does the model now, this time I'm going to generate a rule, and this time I'm going to generate a leaf node with a specific name.
I think this is based on the rule definition.
Yeah, the
example,
rule
yeah.
definition. So you can see, so if we are generating here, right? So
ID
here the ID
is-
is length, right? So here the ID is length. The point that how do we know the ID is supposed to be the length?
The model will
Or
generate it.
yes, yeah, exactly. So I'm asking. So here we will have suppose n equal to 10, all right?
Yes.
So n is basically a name, right? It's a number. And how do we know this number is 10? This cannot be specified by rule. This must be using some word to using some mechanism to generate, right? This is a 10. This is a constant.
Yeah, yes, it's generated by the neural network. No one knows how they generate, but it's
Yes, I know that you may have limit time for the XC for submitting paper in XC, but definitely when you read the papers, you should read those questions by yourself.
but I think all the neural networks are all doing this. They just generate the tokens. I quite not get your
So which
question.
means that we need to have a dictionary, right?
Yes, they do have. They are that's the same as the typical traditional neural networks. What's the difference is that they just generate some rules to guarantee the grammar correctness, because now the code should obey some grammar rules.
So the question that is based on the architecture, so you need to explanation or illustration on when the rule is generated and when the or when the leaf node or when the non-leaf node is generated, right?
No,
So
no,
if
no.
we're generating assignment, there's no need for us to specify which tokens we're going to generate. But if we go for the leaf node, we need to be very specified. The variable name is length, and the constant name or the constant is about 10.
I think you can just regard all the rules is just the one token in the vocabulary. So they just generate the token in the vocabulary. There's no difference from natural language.
So which means that you mean the rules and the rules and the words are encoded in the same way in the dictionary.
Yes.
Are you sure?
Yeah, I'm sure. They are all the same thing.
So which means we're just including the rules combine the rules with the dictionary of the words, and we apply the words embeddings there.
Yes. But they have different embedding. I mean, they have
I know they have different embeddings, but
yeah.
And also there's a way about the composition, right? So just like not like a sequence, we generate it's not like sequence, we generate tokens by tokens. We need a way to compose those components together into a tree.
What do you mean? I not quite get your meaning.
Yeah, just a little bit. Anyway, so I'm just a little bit suspicious on why they put the embeddings of the rules and the words together, right? So by right, they're supposed to use. If I'm the one who designed architecture, I'm going to separate the dictionary of rules and the dictionary of words separately.
Maybe I clarify my statement. So for example, now we go to generate the code. So the first token must be the root. It's just like the CLS in the natural language. Okay, so must be the root, and the root will generate the module, and the module will generate the body.
Of course, we understand this.
Yeah, this is the same. Then the model will choose, because there are several, like body will generate like for, if, or assign statement, for example. So there will be 3 choice. Okay, then the model will
I understand this.
Yeah,
But the question that once we go to the node like ID, right? The name will generate ID, and ID will generate something called length.
Yes.
And here it's okay that the name will be followed by ID because of the rule specified it. But when but now this identifier, the name of this identifier is length, which cannot be specified the rule, right?
Yes, so there will be many choice. The choice is in the vocabulary.
So your point is that you combine all of the rules and words and vocabularies into a single dictionary, or they're
For
different.
example, here there's only 3 choice if there are only if for a sign.
Of
And-
course, I know. So which means that we cannot just simply put them into the same dictionary, right?
Yeah, I mean they are all in the dictionary, but not generally the same because sometimes
Yeah,
it's
exactly. I
only-
know. So there's 2 separate dictionaries, one for rules and one for the word, or one for the vocabulary. A yes or no?
I think only one dictionary. So sometimes they can't generate something. For example, when they generate rule, they can't generate the vocabulary of natural language like.
And now that's so which means that if we are generating an assignment, or when we have a bodies, we have a very limited number of the state choices to go, right?
Yes.
So which means that softmax will be designed in a different way.
No, I think it's from my understanding. There's
So
no.
let me talk about it. If we have a softmax or one hot vector, right? So suppose one dimension corresponding to rules and another dimension corresponding to a vocabulary, a word in vocabulary. All right. So, but
Yeah.
in this case, if we combine them all together, we will have a huge vectors, right? Some dimension corresponding to rules and some dimensions correspond to the words, right? But here, if we are generating the assignment here, we have a very limited choice. So in this case, why do we let the softmax to provide the options of these irrelevant vocabularies? We can just design a softmax saying that there are only very limited choices here.
Yeah, I think it's okay, but from my reading, they just put a softmax.
Right. So they just based on the statistics to saying that the sign will have only these kind of options.
Yeah, they use some neural network to predict whether it is a rule or not. Maybe not rule.
And as for the minute-to-minute, or as for the generative model, so we will have some I forgot the name. So it's called so which means that it's random, right? So because we have the softmax, we will sample the choices based on a probability, right? So which means that if we generate code for several times, and the code will be a little bit different.
You mean beam search?
I mean the model, yeah, beam search, yeah, exactly.
Okay.
So is there the beam search algorithm for this tree generation?
From my reading, they didn't mention that.
So which means that this algorithm is deterministic. Once the model has been decided,
yes,
the tree generation is deterministic.
Yes.
Okay.
Yeah. And I think they are.
But giving there's a formula, right? So which means that it is not necessary to be deterministic. We can apply the beam search on tree as well.
Yes, I think we can do that change.
Okay, let's move on.
Yeah, I think the problem of the paper is that their data set is too small and only few data sets here. You can see that there are only hundreds of.
Then the question goes, what's the number of weights or parameters?
Yeah, and so for enhanced
the question is, so giving the limited number of training data, what is the number of parameters of the network?
They didn't mention that from my reading. I didn't read it, but they.
So I think the code, maybe if we have time for the code generation, I think that is one of the approach we need to investigate. So maybe it's not time for now.
Their settings. They say they are. I think they are similar to the transformer. They have 6 layers of attention.
So which means there are a huge number of parameters.
Yeah.
So which means that they have the risk of overfitting.
Yeah.
Okay, let's move on. Yeah.
So they also use another 2 data sets called Atlas and Geo. So want to enhance the model.
Okay, let's move on. Yeah. Oh, yeah, by the way, there's a question here. So I think it's quite, Yufan explained quite well here.
Yeah, and it's very efficient. You can see that's only 18 seconds for one epoch. So it's quite fast.
Because because the data set is small.
Yeah, quite small. We have about 200,000 data in our
Okay.
data set.
Okay, let's move on. Yeah.
So here is the experiment. So you can see that the current, metric is not quite good, and the performance is not quite good for all.
Could you explain a little
Okay.
bit about the metrics? So we now blue, right? But how about string accuracy and accuracy plus?
Yeah, string accuracy is the percentage of programs that have exactly the same token sequence as the ground truth. So it is exactly the same token sequence.
Okay.
It will be relatively small because
Is that longest common subsequence or
pardon, please.
Longest common subsequence?
What is longer?
Longest common subsequence.
Yeah. Yes.
Okay.
Yeah. And the ACC plus means they just evaluate manually, and so they allows like variable renaming.
Because the number is
Yes,
more, it is possible.
Yeah, they can use manually. Yeah. And
All
then for the plain architecture, they just didn't use, but they are all copy from the idea from previous work. The plain means that they just regard the whole description, the whole natural language as plain text. And for the structure information, they regard the natural language has some attributes, and they will extract some structural information. Maybe I can use this example here. You can see here the attributes will be the name, attack, defense, cost, like this. So this will be a bit different.
Sorry, I missed it. So, what's your point?
I mean, here there's two settings. One setting is called plain. You can in the left column. That's plain, and another setting is called the structure. There are different pre-processed way on the natural language. Yeah, if you are interested. So
yeah, so but anyway, so their input is just a sequence of tokens, right?
Yeah,
so there's no plan and structure difference.
Yes.
Okay. So by the way, there's any question here? If no questions, let's move on.
Okay. Then we'll go to another experiment. So they compare to the traditional modules, and they find that the traditional modules may be better than the neural networks. So I don't know why he put this, but they just said.
But they could accept it, right?
Yeah.
Okay, so they're saying they're their best neural network model.
Yeah, best neural network.
What's their name?
Called Trigen.
Okay, so yeah, Trigen. So which means that they didn't outperform the traditional state-of-the-art, but they do outperform existing. So here you can say it is 2020, right? It already find 9 baselines. So if we're going to involve in this area, including Trigens and the EJK papers, we need to including maybe there's 11 baselines, but then we can just get rid of maybe the work before 2018.
Yeah.
Right.
But maybe we needed to compare with the traditional method, but because in some parts it will be better for use traditional method.
All right, let's move on. Yeah.
Okay, so that's all for the paper.
Okay, so yeah, so I think you find generally clarify the overall ideas. So maybe you can move on. Any question for Yufan? If no questions, Yufan, please go on. Yeah, so this is the part we once discussed before, right?
Yeah, we discussed before, so we have a quick review. So now we have 2 more information. One information is structural relation between the grammar rules, and another relation is the content information of the rule definition. So you can just compare with the previous. I mentioned that the Dr. Xiaoyan also mentioned the rule definition part. So now they want to enhance it. It's not one hot vector. they use grammar, this
Mm.
graph neural network to enhance the grammar information. So I think that's all for the Grape
Mm.
this module. So we
So
just
you're
take
done,
the
right?
idea from my
Okay.
yeah. So you
All
can
right.
see there are also
So-
the rules here, and they now have the structure of the rules. So they use the graph neural network to make different rules have some different information from like other rules. So it will be more rich information.
Okay, so yeah, so that's all for today's presentation.
Yes. Any
All
more?
right,
questions?
so any more questions? Chen Hin or Dr. Xiaoyan, please.
Whether the rules are limited or I mean
Definitely limited,
predefined.
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 Yeah, predefined.
So that's all in the in this slash.
Yeah,
That's
I
all?
think I think it's
No,
supposed to be
they
a few
have
more,
many,
right?
yeah.
100, right? The rules above
Maybe
100. They just list a few example.
Yeah, that's here.
Oh,
Yeah.
predefined. Whether this
Yeah.
rule can be used for different language.
I think it's different by different language.
Different.
So if you want,
different
which means that if you train on Java, you can only generate the rules. If you want to have Python, you need to have a different one.
Oh. Okay, but yeah, I just cannot understand why it's different.
Because their grammar is different.
Oh, okay, I see.
Yeah, but I think it's very interesting if we can have a unified rule across the language,
Yeah.
Yes.
right? So yeah, that's very interesting. So if we have a way to reverse engineer on, yeah, it's very interesting. So which means that if we give in it's more like a conditional gain, right? So once we give in the label of 1, we generate the language of Java. And if we give the label 2, conditional label 2, we generate language of Python, etc., etc. But I think since the rules are very predefined, this condition is usually might be implemented by some rules instead of some statistics network prediction. Okay, so yeah, so this is I think this is all for today's meetings. Since we have XC papers, I think Yufan still busy with baselines, right? Baseline implementation and run experiment. And quite a lot of people are working on XC submission. So I will be in United States next week. So I think we resume our paper reading sessions on September 3.
Okay.
Okay. Thanks everyone for attending the meetings, and I also encourage more of us to raise questions, and so the people like Yufan read the papers, and he have his own understanding, and we raise questions, and through discussions we not only clarify the confusions, but also spark some of ideas.
Yes.
All right, thanks everyone. Let's call it a day then. Bye.